Linear search versus binary search. The very first aspect is definition. The definition of linear search is it sequentially checks each element in the list until it finds a match or until the desired element is found. When it comes to binary search, it divides the search interval in half repeatedly in a sorted list. This binary search continuously divides the sorted list, comparing the middle element with the target value. And also this binary search eliminates half of the search space successively in each iteration. And the second aspect is search space. When it comes to linear search, it examines each element in a linear order. Sequentially, it would check each and every element until the element is found or until the last element. It examines each element sequentially, and whereas in binary search, it eliminates half of the search space with each comparison. It eliminates half of the search space. And the worst case time complexity of linear search is big O of n, and this worst case scenario occurs when the element is not found in an array or if the element is found at the last position in an array. Why? Because since it follows, it performs the searching operation in a linear order. If there are maximum n number of elements are there, means if the element is not found, it has to go through n number of iterations, and also if the element is found at the last position, also it has to go through n number of iterations. So the worst case scenario here is when the element is found at the last position, or if the element is not found, it is going to take maximum n number of iterations. And when it comes to binary search, the worst case time complexity is big O of log n, and this worst case scenario occurs when the element is present at the first position or a last position in an array. And also it is very faster for larger data sets. This binary search method would be faster for larger data sets since the time complexity is lesser, big O of log n. And the next aspect is input requirement. This linear search works on both sorted and unsorted list. It does not require the list to be sorted. So it works on both sorted and unsorted list. When it comes to binary search, it requires a sorted list. Input data has to be sorted either in the ascending order or a descending order. Then only binary search technique can be applied. Next is best case scenario. The best case scenario of linear search is big O of 1, whereas in binary search again it is big O of 1 only it is going to be, and the scenario is the best case scenario of linear search is if the element is found at the very first position, it is going to take only one number of iteration, right. So the best case complexity is big O of 1, and in binary search the best case scenario is if the element is found at the middle position. Why? Because since we use a divide and conquer method strategy here, every time the list would get divided into two. So based on the mid element, after comparing the element which we want to search with the mid element only, we'll start dividing the list into two equal halves. So if the element is found, if the element which we want to search is getting matched with the middle element, means the element is found, right. So during the very first iteration itself, if the middle element itself is our element, the desired element, means it would take only one iteration. So the best case time complexity for binary search also it is big O of 1 time complexity, and use cases are it is suitable for small or unsorted data sets. This linear search is suitable for small or unsorted data sets, and this binary search is ideal for large sorted data sets. When it comes to algorithm type, it follows iterative method, which is the straightforward method. When it comes to binary search, it can be solved using iterative procedure, also a recursive procedure. So it can be iterative or recursive. And the next difference is when it comes to implementation, this linear search is simple to implement. When it comes to binary search, it is more complex. Why? Because we apply a dividend concave strategy, and before we apply dividend concave strategy, we are supposed to check whether the list is sorted. It must be sorted either in ascending order or descending order. If it is not sorted, we are supposed to prefer any of the sorting technique to make the list sorted first, and then we can go with dividend concave strategy. So it is more complex to implement. It requires more complex implementation, but it has fast process. More complex to implement. And next is about efficiency. Linear search is less efficient for large list because it takes more time complexity as big O of n. It is less efficient for large list. If the input list is large, it is going to be less efficient because it performs searching operation sequentially, right. So if there are n number of elements, maximum n number of iterations it would take. When it comes to binary search, it is more efficient when it comes to larger data sets. Why? Because every time it excludes half of the list because it follows dividend concave strategy. So it is more efficient for large sets or large list. And the next aspect is application. This linear searching technique can be used on problems where data is constantly changing. When data is constantly changing, we can prefer this linear searching method. And when it comes to binary search, this can be used on applications where the data is relatively static or the data is updated in batches. When data is relatively static or updated in batches. And next difference is memory usage. Linear search has low memory usage. It consumes less memory. Even in binary search also it has very low memory usage when it comes to iterative version, but higher in recursive. Low memory usage if we follow iterative version, and if we use a recursive version, it is going to be higher. And pre-processing. When it comes to linear search, pre-processing, you no need to pre-process the input list. Why? Because it is applicable on both sorted and unsorted list. So there are no constraints on and the input data. So there are no pre-processing steps which we are supposed to follow in linear search. When it comes to binary search, yes, it requires pre-processing to sort the data. Because this binary search is applicable only on sorted elements, sorted list, right. So if the element is not sorted, we are supposed to apply any of the sorting operations, sorting techniques to sort the input data first. It can be in either ascending order or descending order, but only if the list is sorted, binary search method can be applied. And there are some additional points also. Very first one is implementation complexity. So here linear search is straightforward with a simple loop to iterate through elements, which would make it easy for the beginners to understand and implement. Whereas binary search, while still relatively simple, it requires understanding of recursive or iterative logic to efficiently divide the search space. And the next point is adaptability to dynamic data. Linear search is suitable for data sets where the data is frequently changing, as it does not require any specific order of elements. When it comes to binary search, on the other hand, it is less adaptable to dynamic data, since any change requires resorting of the list, which can be costly in terms of time. And third point is iterative versus recursive. Binary search can be implemented both iteratively and recursively. The iterative version uses constant space, while the recursive version uses additional space proportional to the recursion depth of big O of log n. And linear search is typically implemented iteratively using only the constant space. And the next point is performance consideration. In scenarios where the data set is small or the cost of sorting the data is higher than the cost of searching, linear search is preferred, because for large data sets where sorting is feasible and the data set remains mostly static, binary search is much faster due to its logarithmic time complexity. So, when you compare, the linear search time complexity is going to be big O of n and the binary search complexity is big O of log n, right. So, comparatively, since binary search is taking lesser time complexity, binary search is the preferable method to perform searching operation. Why? Because every time it divides the list into halves and it prefers divide and conquer strategy, whereas linear search uses only the iterative procedure. So, if there are n number of elements are there, n number of iterations it is supposed to take, and also if the list is huge, also linear search is not going to be the preferable one, since it consumes much time complexity. And the next point is use in practice. Linear search is often used in real world applications where data is not sorted or sorting is impractical. Binary search is widely used in applications that require fast lookup times in large sorted data sets, such as database indexing, dictionary lookups, and large scale data processing. And one more point also there, error handling. Both search algorithms, linear search and binary search, can handle cases where the element is not found in the list. Linear search will naturally reach the end of the list without finding the element if the element is not found, while binary search will reduce the search interval to 0. Thank you.